Hello and welcome to this section of the Calculus Derivative Tutor. In this section we're going to continue working problems that involve the quotient rule. So in the last section we worked a few problems to kind of get your juices going, show you how to use it. Hopefully you got some great practice from that. In this section we're just going to continue doing a few more problems, maybe get to a little more complicated things, but really just keep in mind that none of it is more complicated than what you've already seen from a big picture point of view. What really happens is that when you get into more complicated functions, you just usually have a little more algebra to do. So it's usually a matter of getting your algebra skills pumped up so that you can simplify the results. And so we're going to practice that here. So our first problem is going to not look so bad, really. Let's go ahead and work the following guy. F of x is equal to 1 over x to the power of 4 plus x squared plus 1. So at first you might look at this and say, how do I do this? I've never learned how to do one like this. But when you think about it, anytime you have 1 over a function, this is itself a function on top. It just happens to be a constant 1. This one is also a function. So you can use the quotient rule on this without any problem at all, because even though there's a number up here, it's still in general a function. Right? It's just a constant. It's a flat line, right? So you can still use the quotient rule on guys that look like this, but this will trip up a lot of students initially because in the beginning you won't realize that you can use the quotient rule on something like that. So that's all we're going to do. F prime of x. How do we use the quotient rule? Recall from the last section. All it is the bottom function, x to the fourth plus x squared plus 1, times the derivative of the top function. So here we have the number 1, we need to take its derivative, so we'll mark it like that. Minus the top function, which is this, times the derivative of the bottom function, plus x squared plus 1, and we need to take its derivative, so we'll mark it like that. Over the bottom function, x to the fourth plus x squared plus 1 squared. So here we've done exactly what the quotient rule tells us. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. All right, so let's go ahead and do our math. Let's do our calculus. F prime of x is equal to x to the fourth plus x squared plus 1. What is the derivative of a constant number 1? Well, that's going to be 0. So we'll just put it in there like that, minus. This is going to be 1. And this is going to be a derivative we need to take. What is the derivative of this term? 4x cubed. We take the exponent down, subtract 1 off the exponent, and that's what we get. Plus, this guy is going to be 2x. The derivative of this is just simply 0, so we leave it off like that. So we've taken that derivative. We need to divide the whole thing by, this is just simply rewrite, x to the fourth plus x squared plus 1 squared. Okay, let's go ahead and I think we were pretty darn close to writing the answer down. F prime of x. This entire first thing drops out because it's multiplied by 0. Then we have a negative here, so we'll have a negative, then we'll have 4x cubed plus 2x on top, and on the bottom we'll have x to the fourth plus x squared plus 1 squared. And like I say, if you wanted to, you could expand this bottom thing out, but you would have a really long polynomial term on the bottom. It wouldn't really cancel anything, so it would just better to leave it tidy like this. So this is the answer. On the top you'll have negative 4x cubed plus 2x, and on the bottom you'll have x to the fourth plus x squared plus 1, all raised to the power of 2. So again, doesn't look too bad. I mean, it's really only 4 lines. And when you get a little bit better in calculus, you really can kind of do these derivatives as you're writing them down, but I always like to show them, because especially in Calculus 1, if you write it down like this, even if this is pretty simple, so you probably wouldn't take a derivative, but if you took a derivative incorrectly somewhere, like maybe you took this derivative incorrectly, and you didn't show your work, I wouldn't know if you knew what you were doing or not. But this way, at least I can see, well, the student knows they need to take this derivative. They just kind of made this little mistake there, so they mostly knew what they're doing, so I'll give them most credit. But if you don't do this and you just dive straight into taking derivatives, it's going to be hard for me to justify giving you those points. So definitely do yourself a favor. I mean, come on a test, an hour test or an hour and a half test, it only took, 1 minute to write that extra line, so do yourself that favor. All right, the next problem looks what I would call a little bit more challenging. Y is equal to square root of x minus 1 over square root of x plus 1. Now here's a great example of a function that looks really intimidating mainly because it has these square roots both places. And so you might, at first, if you're not on your game, you might say, well, square roots everywhere, you know, we really haven't learned about how to do that. But we have, because remember, any radical like that, square root, is just exponent of 1/2. So if I have to give you a piece of advice, and I think this applies to pretty much everything in calculus, and in fact I can say with honesty, pretty much everything in calculus, if you see a radical, first thing you should do is rewrite it as an exponent that's a fraction. Because almost always it's going to be easier to deal with those fractional exponents than it is to be dealing with these radical symbols in your head. And you just have to trust me a little bit on that. So they write it like this. Notice I did not write x to the 1/2. I wrote it as this. That's entirely the point, to try to trip you up into seeing if you know what you're doing. So the first step before you do anything is write the function over again. X to the 1/2 minus 1 over x to the 1/2 plus 1. So you might think, well, this is even uglier. I've got fractions everywhere. But trust me, folks, when you start taking the derivatives, it's going to be easier. So let's go and do that right now. We're going to work with this function and take its derivative. Y prime is equal to the bottom, x to the 1/2 plus 1, times the derivative of the top, x to the 1/2 minus 1. Minus, and I got to take this derivative, because this is the bottom times the derivative of the top, minus the top, x to the 1/2 minus 1, times the derivative of the bottom, x to the 1/2 plus 1. Take its derivative over bottom squared. X to the 1/2 plus 1 squared. Okay? All right, now we need to take some derivatives. Let's go ahead and do that. So we'll have y prime is equal to x to the 1/2 plus 1. How do we take the derivative of what's inside of these parentheses? And this is where the real beauty of rewriting it like this is. Because if you had a radical x, square root of x here, you might not remember how to take its derivative. But now that we've written it as x to the 1/2, it follows exactly the same rule as you apply to take the derivative of x squared, or x cubed, or x to the 19th, or anything like that. You just take the exponent down, 1/2, x to the, and you subtract 1, 1/2 minus 1. 1/2 minus 1 is negative 1/2. Convince yourself of that fact. 1/2 minus 1 is negative 1/2. So yeah, it looks ugly, but as long as you give yourself enough room in your paper to write everything out, it's actually going to be easier. So we take the derivative of 1, which is 0, so we can just close our parentheses off. Now we subtract what we get over here, x to the 1/2 minus 1 times the derivative of this term. This is going to be the same thing. 1/2 times x. 1/2 minus 1 is negative 1/2. Derivative of 1 is 0, so I just close it off. And again, on the bottom, I need to rewrite what I have. X to the 1/2 plus 1 squared. And again, it looks like a monster, looks ugly, but it's easier. You're just going to have to believe me a little bit here. So now let's multiply y prime. What we're going to do is multiply this times this term and then also multiply it by this term. What we're going to have is, when we multiply these guys, we're going to have 1/2 x, and we have to add the exponents. This is just like x squared times x to the third. You know, if we have x squared times x to the third, it's x to the fifth. You know, we know this. We just add the exponents. Here we have the same base, so we add these exponents. But 1/2 plus a negative 1/2 gives us 0. So I'm going to write it as x to the 0, which later on is just going to drop away and give us 1. But for right now, leave it as x to the 0. This 1/2 comes from here. Next, we have multiply by this term. So we're going to have 1/2 x to the negative 1/2. Okay, and we can just wrap this up in parentheses if you want to make it tidy and say, well, this comes from this. Next, we need to do this multiplication. I'm going to keep my subtraction outside to keep it clear, and now I'm going to do this multiplication of this and then this multiplication of this. So when I do this one, I'm going to have 1/2 times x. I'm going to add these exponents, and I'm going to get 0. Next, when I multiply these guys, I'm going to have 1/2 x to the negative 1/2, and I'm going to close this guy off like that. And on the bottom, I'm going to have x to the 1/2 plus 1 squared. All right, now is finally the point where I can get to some real simplification. Because x to the 0 is 1. So it's really going to drop away. So on the top I'm going to have 1/2, and that's all I'm going to have for this term, plus, and then I'm going to have 1/2 x to the negative 1/2, right? And then over here, let me distribute the negative in. I'm going to have minus. This guy is 1/2. X to the 0 is 1, so it drops away. So I have a minus sign here. Next, I have a plus sign because of this, and I'm going to have 1/2 x to the negative 1/2. And on the bottom, I'm going to have x to the 1/2 plus 1 squared. So what I'm going to have now is, when you notice, the 1/2 here cancels the 1/2 here. All right, so if I had to rewrite this here, let me just rewrite it over here. What I'm going to have here, when you look at it, is I'm going to have, notice what I have here, 1/2 x to the negative 1/2 plus 1/2 x to the negative 1/2. So I've really got the same thing here. This is like adding, let me just do a little aside here. This is like adding 2x squared plus 3x squared. It's 5x squared, right? Because you have the same guy here and the same guy here, so you just add the coefficients. Here I have the same guy here as I also have here, so I can just simply add the coefficients. All right, so 1/2 plus 1/2 is 1. X to the negative 1/2. So on the top, I'm just going to be left with x to the negative 1/2. That's all I'm going to be left with on the top. These cancel, these simply add together. On the bottom, I'm going to have x to the 1/2 plus 1 squared. Now, technically, I was done with the answer even up here, but I could probably even circle this and say this is my answer. But since the original problem had radicals everywhere instead of x to the 1/2, it's kind of polite manners to rewrite it in terms of the way the original problem was given to you. So if I had to do that, y prime would be equal to, this is x to the negative 1/2, so let me move it to the bottom and make it positive 1/2. So it's going to be 1 over square root of x, putting it back in terms of a radical, times square root of x plus 1 squared. And this is the answer. 1 over square root of x times square root of x plus 1 squared. If I wanted to, I could try to expand this out, try to simplify more. I don't think it's going to get any more simplified than it is right now. But notice that in this whole problem, once I got past the initial calculus of, the quotient rule itself, it just became algebra. And that's always the way it's going to be in calculus. You're really going to be constantly flexing your algebra muscles. Because once we actually got to this point, we take these derivatives, and that was calculus, all right? That we know how to do that. But everything beyond that point was just algebra. Multiplying this in, adding the exponents. Multiplying this, getting this. Multiplying this, adding the exponents, getting 0. Multiplying this, getting this term. And then we know that x to the 0 is 1. So these 1/2s come here, this term drops down, multiplying the negative goes here, multiplying the negative times the negative gives me the positive. The 1/2s cancel. These guys can add together to give me 1 times x to the negative 1/2, and then we just drop it to the bottom, rewrite it in terms of radicals, and we're done. Okay, we're going to do another problem here and show you how to use the product rule, but again, I'm trying to drive in over and over again. The actual calculus of it is not a big deal, but once we get into the algebra is usually when a lot of the mistakes are being made. Because it's easy to do if you don't show every little step. So what we'll have is f of t is equal to the following. T squared plus 5 times t plus 4 divided by t squared plus t minus 20. Simple enough looking function. We have something on the top, something on the bottom. So we know we're going to be using the chain rule. So let's go ahead and do it. F prime of t is equal to the bottom, t squared plus t minus 20 times the derivative of the top, t squared plus 5t plus 4 prime. Now I'm going to run out of room if I keep writing over here. So what I'm going to do, I have bottom times the derivative of the top minus the top, t squared plus 5t plus 4 times the derivative of the bottom, t squared plus t minus 20. That's the derivative. And the whole thing is over the bottom squared, t squared plus t minus 20 squared. So make sure you understand that. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And again, if you don't put hooks on your little t's everywhere, you're going to get massively confused anytime you have a function of time. So do yourself a favor and get in that habit right now. So let's go ahead and take these derivatives. F prime of t. This is simply a rewrite, so we'll have t squared plus t, t squared plus t minus 20. What is the derivative of this term here? It's just a polynomial, so the derivative of t squared is 2t. The derivative of this is 5, and the derivative of this is 0. So we'll close this off. And I think I might barely have enough room to write this, so I'll go ahead and open this up and say t squared plus 5t plus 4. That's this term. What is the derivative here? I'm going to have derivative of this is 2 times t, and the derivative of this term is simply 1, because it's the only thing sitting out in front of the t. We've learned how to take these derivatives before. This is a 0 when we take its derivative. So now we have a bottom of this, t squared plus t minus 20 squared. So at this moment, you have the derivative. If you plot this function, it is the derivative. But I can almost guarantee you, if you leave your answer like this, you're probably going to get some points knocked off because you didn't even make an attempt to simplify it. So roll up your algebra muscles, and let's get rolling on that. So we'll have f prime of t. What we have here is a 3-term guy times a 2-term guy. So really the way you multiply that, if you don't remember, is you just take, you can go either way you want, but I'm going to take this guy, multiply it by each term, like this, and then I'm going to take the second guy and multiply it by each term. Basically what you want to do in the end is make sure that every one of these terms is multiplied by every other one of the terms. So let's start with the 2t and multiply it by this. So what I'm going to have is 2t cubed when I multiply these. Next, when I multiply these, I'm going to have 2t squared. Next, when I multiply the last guy, I'm going to have 2 times 20 is 40, so I'll have minus 40t. Okay, minus 40t. So I'm going to close that off. This, actually I'm not going to close it off yet. This comes simply from the first term multiplied by every other one of the terms, but I still have this. So I have to multiply this times this, and I'm going to get 5 times t squared from this multiplication. Then I'm going to have this guy, which is 5t. Then I'm going to have this guy, 20 times 5 is 100. It's negative 100 in this case, like this. And I'm going to close it off because this, everything that comes in here is coming from this multiplication here. I definitely don't have enough room over here, so I'm just going to subtract from here and open up another bracket and do this multiplication, which is going to be done exactly the same way. 2t times this is 2t cubed. This times this is 10t squared. This times this, 2 times 4 is 8, so I'll have 8t. Now moving, that's everything multiplied in this direction. Now moving to the last guy, 1 times this is t squared. 1 times this is 5t. And 1 times this is 4. Close it off. And then that's everything is going to be divided by the bottom. T squared plus t minus 20 squared. Now you see why I'm changing colors. You don't have the ability to really change colors too easily on your paper, but I do on the board. So you see what I've done here to make it easy on myself. I have this guy in the front, that's fine. I left this negative out in front and did the multiplication. If I tried to handle the negatives all at the same time, it would give me problems. Now, I could erase all these pluses and just stick minuses in, but I honestly hated when professors did that. I was like, look, if you're going to work the problem, work it just like I'm going to work it on my paper so that I can see if I'm right. So this is what I'm going to do. I'm rewriting this. 2t cubed plus 2t squared minus 40t plus 5t squared plus 5t minus 100. That's the top. But I'm going to continue on under it, minus 2t cubed minus 10t squared minus 8t minus t squared minus 5t minus 4. And the entire thing is over this guy. T squared plus t minus 20 squared. So it made actually quite a bit of progress, even though it doesn't look like it. Now we're ready to really simplify. F prime of t. First, let's look for the t cubes. This is going to cancel with this negative t cubed, right? So we're done with that. Next, let's go ahead and just look at the t squares, right? I have 2t squared, I have a 5t squared, and then the negative 10t squared, and I have this guy right here, all right? So when you look at it, 2 plus 5 is 7, right? So 2 plus 5 is 7. 7 plus the negative 10 is going to give me negative 3. Negative 3 plus the negative 1 is going to give me negative 4. So I'm actually going to have negative 4t squared right here. And that comes as a result of this term plus this term plus this term plus this term. And I've already gotten these guys, so I'm marking off what I've handled. Next, I have negative 40t plus this 5t. That's going to be negative 35, right? And then I'm going to add this guy. Well, let me go do the negative 5 here. So this is going to be negative 35. This is going to be back to negative 40, because really when you look at it, the 5t cancels with this negative 5t. Let's do it that way. Let's move over here. Negative 40 to negative 8. It's going to give me negative 48. Negative 48 times t. That's this term plus this term. And I've handled this but the cancellation. The only thing left is the negative 100 and the negative 4. So I'm going to have negative 104. And on the bottom is going to be t squared plus t minus 20 all squared. Now really this is the answer, but just for brownie points, let me rewrite what we just arrived at just a minute ago. F of t is equal to negative 4t squared minus 48t minus 104 over t squared minus, plus t minus 20 squared. Okay, this is the answer, like I said, pretty darn simplified. But if you wanted to simplify it even more, you would notice that you could pull out a negative 4 on the top. So f prime of t, I could pull out a negative 4 on the top, which would leave me with t squared plus 12t, right, plus 26. That's when you factor out the negative 4. And on the bottom, you'll have t squared plus t minus 20 squared. That is the answer. So on the top, you have negative 4, open paren, t squared plus 12t plus 26. On the bottom, t squared plus t minus 20 squared. So there you have it with the quotient rule. It's the same thing we've been doing before. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. In this case, when I say it's a more challenging problem, it's really not any more challenging other than the fact that you have all of this algebra to deal with. We had to multiply term by term here to get everything on the top, multiply term by term here to get everything there, and then make sure we have all the signs correctly, simplify all the terms, and get it down to a form that was simplified, which is this. Truthfully, when you're on an exam, you're going to have the latitude to take it as far as you want. If you're really crunched for time, if you've got 10 minutes left, 4 problems to do, just take the derivatives, don't simplify them, circle the answer, move on to the next problem, definitely. But if you have the time, you're going to be expected to try to simplify these things as much as you can. And a lot of calculators nowadays will help you do this too, but I'm showing all of the steps explicitly so that you know exactly how to go ahead and do it without the aid of a computer or a calculator. That about does it for the quotient rule. We could do 20 more problems, but they would all be the same. It would be the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And in truth, as we go forward with more types of derivatives, we're going to end up using the quotient rule in addition to the other techniques when we get to the more complicated problems. But just keep this in your mind. If you're able to follow this, if you're able to understand it, and I think that all of you are, then you're going to have absolutely no problem with taking derivatives in calculus because they're bulletproof. When you identify it of a certain form, top over bottom for instance, and you know what to use, quotient rule in this case, then doing it is going to be very mechanical. You're going to be able to get the answer. There's not that much technique to it other than just knowing what to do. Later on in calculus, when we get into integration techniques and doing the other part of calculus, there's a whole lot of technique to that that you really have to have a lot of practice with to be able to know what to do. But with derivatives, if you're just trained properly, you can take the derivative of any function you want without any problem at all.